Emma Morano was the last person to have been born in the 19th century. She was 102 when the Human Genome Project was first published and had just turned 80 when Copaxone received FDA approval. In the year that man landed on the moon, Emma was looking forward to her retirement. Elvis was for young people, and she was already 55 when the newfangled WideSat computer came to life for the first time. She got married before penicillin was discovered and divorced before nuclear fission. And as a young woman, she was perhaps vaguely aware that a patent clerk called Einstein had come up with some equation or other. Emma Morano was born on the 29th of November, 1899. Her lifespan would cross 3 centuries, a quite extraordinary example of longevity. Before she died at the age of 117, she was asked what was the secret to her long life. The answer: stay single. If only it was so simple.
Looking at the topic of longevity, I think we all ask our questions whether our enemy is death or our enemy is disease or dependency.
Longevity is another way of saying that we want to extend our life, especially when we get older.
100 years ago, life expectancy was about 42 to 43 years. Today it's 82 to 83 years. So we basically double life expectancy in 100 years of research. That has created problems, which we all call quality of life.
I think the major question is whether we can, keep all the system working properly, not just, extending that.
And I think science here can really provide a lot of answers.
We have corrective built-in systems. The immune system continuously performs surveillance of all our organs, our neural systems, our cardiovascular system. And it is when these fail that we start to lose very quickly the entire homeostasis and well-being of the person. So being the Weizmann Institute, we're actually looking for understanding the fundamentals behind aging, longevity, disease progression.
How you can keep your body functional.
Maintain good cognitive ability.
Restore function of the heart after disease. I'm talking about heart attack.
To understand mechanisms of age-related diseases in order to delay, prevent these diseases.
We all know that some animals can regenerate some organs, like salamander can regenerate their tail, but very interestingly, the fish can also regenerate the heart. If this fish would have heart attack, he will be able within 1 month to recover completely, swim happily without any problem. That's not the case for mammals. We cannot repair the heart. What my lab is looking, is there anything there back in the embryo or in other organisms like the fish that can be identified, and these molecules can elicit this renewal or repair of the heart. That could be really a key targets for drug development for heart disease. And we have identified such a drug, and this is a major breakthrough in the field of cardiac regeneration, and I'm really, really excited about the possibility that one day, not too long from now, we might be able to translate that to treatment for patients with heart disease.
We study a field that calls cellular senescence. That's what happens to cells when they stop proliferate, but they perfectly fine. These cells accumulate with age, and also these cells are involved in the variety of age-related diseases. We want to understand how the cells stay alive for a long time in the organism, and by understanding this mechanism, we want to understand how we can remove them and improve the quality of life.
We were born with systems that constantly taking care that our musculoskeleton will keep functional. As time passes, the system responsible for this maintenance slow down, and then you start accumulating problems. What happened when you fracture one of your bones? We found that bones, at least some of them, has the capability to correct the angulation that formed as a result of the fracture. And what we found is that inside the muscle there are special organs which act like a small brain that can feel how much the muscle is stretched, and then it can correct it. By understanding both the mechanical and the molecular side of it, we will know how to control it and extend the time that these systems work.
The chronological aging is not as important as we used to think. Aging of the brain reflects aging of the immune system. In other words, you may find individuals with healthy mind that they are very old chronologically, and you may find young people with very impaired cognitive ability. And that's the mystery that I'm working on. There is a specific interface between the brain and the blood where the immune cells can sit and speak with the brain from afar. And this interface is critical for maintaining the brain and for helping the brain to repair or to go back to equilibrium. We are finding now ways to rejuvenate this interface and thereby to restore the brain ability to repair itself and restore some of the function that has been lost.
So we really need to get everybody together, and this is what the Sagol Center would do to make sure that in our pursuit for a better, longer life, we would actually be creating also a holistic view of the entire body.
That the whole world is interested in longevity, and there is a revolution coming.
The secret for a very long life is very well known.
For me, it's swimming.
Longevity is all about not being stressed.
Probably the secret for long life is to make them meaningful.
I think it would be a content life where you're doing what you love, you're surrounded by people you love.
The secret of a long life to me is a very fruitful and a happy community life.
For me, joy of life is the science and my family, family and science.
And I hope we'll see at least another 50 years, if not more, of a happy journey together.
Hopefully.
I don't have a secret. I'm only 53.